Hello, everyone. Welcome to City Futures Research Center Seminar Series. I'd like to acknowledge we are meeting today on the traditional land of the Bijiko people of the Euro Nation, and I'd like to pay my respects to the elders past and present, as well as to any First Nations people joining us today. If you're joining online, please mute your microphone and turn off your camera during the presentation. Once we get to Q&A, you're welcome to turn your cameras back on and unmute yourself. You can also put a question into the chat, and we'll be monitoring the chat for questions. Now, I would like to hand it over to Professor Chris Pettit, who will introduce today's presenter. Thanks, Chris.
Thanks, Fatima, and welcome everyone to the Friday seminar presentation. So it's a great pleasure to introduce Dr. Balamurugan, who is a Senior Research Associate at City Futures. He's been with us for about 5 years, working on a number of analytics projects, including the Housing Analytics Lab in Value Australia. And so today, I'm very excited to hear the latest updates on MapAI. Thanks, Bala.
Thanks, guys. Good evening, everyone. Thanks, everyone, for the time, and thanks for coming. And it's a privilege to present the project, which I've been working on for the past 1.5 years, which is MapAI. So today I'm putting enough stuff for 45 minutes to talk about that. So before we start, I would like to acknowledge the country. UNSW is located on the territory of Bijiko, Gadigal, and Numbal people, who are the traditional owners of the lands where each campus of UNSW is situated. To outline what we're going to be talking about, what I'm going to be talking about today is we have a total of 60 minutes, leaving 15 for discussion and 10 for housekeeping and introduction. So I'm going to spend equal time in setting up the background for the project, the technology behind what we built, and in terms of demo, give a good amount of demos and talk something about a little bit about the future, where we can go. So to introduce myself, thanks very much for the introduction, Chris. So as Chris mentioned, I'm a planner by profession, and then I went on to do masters in spatial analysis and did my PhD in quantitative geography. I worked across transport planning, real estate, project management, consumer data research, and past 5 years I've been with City Futures, working on data analytics across a lot of projects. I wear a lot of hats in City Futures and UNSW. My primary hat is being a researcher. So I specifically look at data analytics in geospatial data, large-scale geospatial data. Past projects are Value Australia, ADAP. I'm currently working on Housing Analytics Lab, and I've had a project on data hunger, rentals. So the new one, the past year I've been working on is the MapAI project, which has been graduated and spun out as a company. So I take 3 roles in there. So one is a co-founder of the company, leading the research and development effort from the UNSW side, and do the data and modeling aspects within that research and development. In addition to this, I do a lot of bits and bobs around technology across City Futures, ADA, and UNSW. I manage the City Analytics Lab, CFRC technology team, and part of the AI working groups in the university. So before I go deep into that, I just wanted to show a glimpse of what's MapAI, give a 30-second pitch of what's MapAI, and then introduce the team who built that. So the MapAI is kind of combination of 3 Gs, 3 components. The primary one is generative AI. So it's a generative AI system which has a LLM as the core, and it basically enables it to process and understand natural language queries, inputs. The second one is it's a GIS system. Basically, it does geospatial analysis. And it kind of works with the LLM to do the geospatial analysis. And the third one is the geodata. So it has a collection of geodata sets in them, which works with all 3. So when you put all 3 together, and connect them seamlessly, it kind of becomes a game changer in terms of like enabling people to in across industries to do things with geospatial data, which they might have never imagined to able to do. So essentially, the core of the project is going from this. What's shown here is like a traditional GIS system. A person is trying to find land parcels which are flood prone and trying to find a aggregate measure on those land parcels. So it involves like going through selecting, creating, and then finally finding the answer you want. From this to moving to something like this, where you don't need to know the data sets, you don't need to know how to do analysis, you just start talking to the maps. So that's actually a real query, a real app where you start asking like, show me all the flood prone areas in Eastwood suburb. And then you start asking like, how many are there? And you ask, you can ask basically like, what's the total area under those, and show them in hectares. So that kind of is like a 30-second, 1 minute pitch on like what MapAI is. Before further, I wanted to introduce the team. So past year we have grown considerably. So it have we are like 12 members across 3 organizations, which being UNSW, Frontier SI, and MapAI. And we have in both cities in Melbourne and Sydney. It's kind of not explainable in a 45-minute talk, like how much effort that went on to in the last year in creating what we have done. Basically, like it's a privilege to work with and like privilege to be presenting all the work we have done in the last year. So in terms of so moving forward, like so basically like I wanted to start with like some origins of where the idea and like where the work started from and where it put kind of how we developed it up. So in terms of origin, I would like to go really far back. So I like showing starting from this because this shows that like whatever we talk about AI is not new. It's always it's one of like the oldest in terms of computer science. Like the research is really old. And also, it's not a constant up. It's not like a constantly upcoming field. It has a wave. So basically, like around from 1950s to 75, that was the first AI summer, as people like to call it. So there has been a lot of activity, a lot of innovation that went on there. Then there was like a period of lull, and basically currently we are in the current. It's an AI summer, the longest one I think since 2005. So the reason one is completely fueled by the amount of data which has been available with the advent of internet, and basically all the concepts and research from the 70s and 60s has blossomed into like a full-blown usable AI systems. This shows like how crazy it's been like in the last 6 years. Basically the graph shows like how the AI performance have reached human level of human level. You can see for handwriting recognition, what used to take like for 20 years, 20 odd years has been done in language understanding by AI within like two years. It just like the generative AI, the amount of application possible and the capability of AI system just exploded. So within this context, like basically last year I did this CFRC seminar talk. As you can see, similar shirt, changed much. I talked about a lot of things there. So the core was about visualizing spatial data. So I went through what are the technologies which have been using, showed like a bunch of stuff we did in CFRC, city futures, and finally at like the last bit, I kind of talked about the experiment in terms of language model assisted maps. Went back and like analyzed the things. So basically out of my talk, 95% of the time I talked about something else, and 5% was about the MapAI and stuff. When it came to discussion, literally that's what everybody was interested in. So it's the core of it is like it kind of shows the potential for people. People intuitively understand the potential, and it generates a lot of interest in terms of what we can use it for. This is the proof of concept I showed last year. So the project we did with Chia, with Brian. So basically, what we did is like we had a research which had an output of housing need across LGAs in Australia. It's like a table of housing needs, and then we kind of like put GPT 3.5 to allow people to be able to explore the map. So you can start like asking questions in terms of like what's the percentage of housing need in Sydney, and then start thinking about like, okay, what's 50 kilometers from Sydney, like what are the LGAs there? So this was the like entire proof of concept back then, and basically like kind of showed the potential of combining like the geospatial data and analysis with LLM. That kind of started the whole idea in terms of like what we can do with it. So this is me then predicting what I'm going to do in the future. So analysis. So I even have a code. So they need to do that like basically like this is what like a very new version of me is told about like I'm going to be done with it like in the next few months. I'm going to implement all this, and that did not happen. So we've been doing it for like 2 years now. So it kind of like went. We shared the journey with like how overall AI has been developing as well. So ChatGPT was announced like 2022, late 2022. The seminar proof of concept we did in March. And then Chris, thanks Chris for like giving the support which the idea needed. And we had like we had initial talks with Frontier SI, and they started talking about like getting that up from the ground. So MapAI project was started in October 2023. So from October to March, we kind of like worked on the first cannery. I know like few people who attended the first workshop we did, where we got to use the initial AI and give feedback to that. And then the second one, like we finished around March this year. We had the working prototype. We did like a real world use cases with 3 partners in Q3, and then we are working towards a public working demo by the end of this year. So that's been like the overall journey across the project's time. But we worked in like broadly 3 stages. And the first stage has been setting up the basics. So last year we spent a lot of time getting the basics up, like setting the infrastructure, working with UNSW IT and AWS, getting to do the base work for creating the systems, developing the LLMs and the toolkit that goes alongside. And second stage was once we had that initial proof of concept with a demo, then it kind of iterating over that and developing real world use case based proof of concepts with that proof prototype. So we worked with 3 partners, city councils and like commercial partners. So, and then basically we also made the base work of scaling that into a actual product. So, so the stage 3, which we've been in currently, we have been trying to iteratively improve over that proof of concepts we have, while building out the production capabilities of the model so that we can actually deploy something which people can use. The project's been funded with our partner Frontier SI and UNSW as well. So like to acknowledge industry innovation. So their contribution and support for the project as well. The product has evolved from a single table system to a bit more complicated. This one had like a full database of spatial collaboration portal data from New South Wales, where you can actually ask a bit more complex questions. to a full-blown conversational portal where you can actually hold a conversation with the AI about the data. So that was like where the background of the project comes from. To summarize, basically, like it started with us working on looking at how do we improve like output of a project and make it more accessible to users. So we started exploring using LLMs to make it more accessible for users, and that idea kind of like steamrolled into like bigger application which helps people to do geospatial analysis using natural language. We've been working with UNSW Knowledge Exchange, Frontier SI, and now a team of 12 people working towards making this into a reality. And we also spin out MapAI as a company, which is trying to get this up and running. So how did we do it? So that's the next part where like we kind of wanted to go into the details of it. So coming back to the three components we have, that's generative AI, GIS, and curated data sets. So the first part is the generative AI, which is the core part of it. So I was debating whether to like go deep into this or not, but I thought like my people might enjoy a oversimplified explanation of what we are doing. So I'm not sure everybody has seen this circles of AI. So AI is a broad term out of which like we go deeper into that. So generative AI is like a very specific set of AI which uses neural networks and deep learning techniques and creates like large model space using them and generates artifacts such as text, images, code, and even 3D. So for example, if you take considering just text, I'm trying to give a simplified explanation. So let's say I have the sentence, which is UNSW Sydney is world leading university. So I have that sentence there. Then what I can do is like then first I can segregate into words or like tokens, as they call it. Then I can make a mathematical representation of that, which is like a vector, which is a embedding. So this vector will, for each token or like a word, it has a meaning and the position of it, so it embeds that. So once we have that in a mathematical form, a vector form, then we also try to attach the meaning with where it is in the word. So it can be forward and backwards. So basically that's the attention. So you have a context looking backwards or forwards. So based on whether the word, what they actually like, what the word is associated with. So that's the attention. So once we do that for each and every token, then what we have is like this, the same sentence now has become like a representation which encapsulates its meaning and its position and its relation to other words in the same sentence. So once we have that, then we can use a neural net. Neural nets are really good at predicting stuff given certain inputs. So then we can start removing a value and like try to fit the neural net to predict that value. So essentially, we are making a text into a mathematical representation, and then training a neural net to predict what's the next step in that representation. So once we train that. So that's the pre-training part where we train the neural net to do the prediction. Then we can start doing it iteratively ahead. So for example, then we can start predicting the next one and the next one and so on and so forth. So let's say we predicted 2 words in the two tokens in the ahead. What we can do is like we can start unembedding the thing back to the text. So now the last 2 tokens we predicted can be made into words, so which gives us like a worldwide. So essentially, like what the model has done is predicted what would be the next 2 words. So this looks very simple. It's a very oversimplified version of what an LLM does. Of course, there's multiple layers of attention, multiple layers of the neural nets work in conjoint to do that. So if we have billions of these sentences and billion parameters in the model, then we can start making the model do much more like predictions much faster. So once basically that has been the key in LLMs is like basically they predict what's next and it starts generating text once initial text has been given. So that's good for like a toy. Basically, if before 3.5, it used to be that playgrounds we used to have from OpenAI, where you start the prompt and then it will write a story for you, like for the next 500,000 words. The key breakthrough was like, then how do we use this, right? So how do you make it useful for us? So that was basic. What people realized is like, if you have enough data in that model, enough parameters in the model to capture the data, if you model the language, then you're actually modeling the meaning which the language says, which is almost everything in the world. So all the concepts get into the model, or some memory as well gets the model. So essentially, this is like someone wrote forum. We said a good language model, a comprehensive language model, can actually model the whole world, our understanding of the world at least. So then the breakthrough is that then you can actually start structuring some examples in terms of a conversation. You say that like, okay, so there are two people, one person is saying this, other person is saying this, one person is saying. So then you start training the LLM to predict the next step using these templates. So it becomes like a bot which can actually chat with you. So after training it on these 4 examples, then you can ask saying like, okay, what's the time? The LLM tries to fill that with the time is 4:30. So the problem is like it doesn't know when you ask that, so it's just trying to come up with that time on the fly. So that's useful, but not useful in a certain way. So the other part of it is like the code generation stuff. So where you can actually train the LLM on not natural language on code, then you can instruct tune to generate code for a natural language input. So this one, basically, we're giving it 4 examples of Python. So if somebody asks this is the Python equivalent for that. If somebody asks this, so then we can ask like, what's the time in Perth? So now it's not trying to guess what's the time in Perth, but basically the completion is of a code which will give you how to find the time in Perth using 2 libraries, which are like a time zone and time library. If I get another system which can run this code and couple with this, then it becomes like an agent which can actually do stuff for us. So in this, this is where how MapAI tries to do the code generation for us. So that's what we're trying to do with MapAI in like training the LLM to actually doing stuff for us and creating all the tooling around LLM to enable it to like understand what we say and enable it to do the things which we want, right? And give us the insights back. There are 4 places where we can impart knowledge into the LLM. One is pre-training. That's the most expensive one, OpenAI, Microsoft, Google, they are doing. That's like looking at like large amounts of data and like having a huge parameter models on them, like training on them. And the next 2 steps is like what we have been focusing on is the fine tuning and reinforcement learning. And the final one is the prompt engineering. Fine tuning is basically you have a pre-trained model, then you want to inject some information like it injects some sort of like behavior into it. So that's the one which we did with similar to the one we instruct tuning. So we set a structure and then we kind of train the model to generate that same structure. Alignment is essentially with a reward function, you kind of like guide the model to act in the way you want to act. This is mostly used for like ethical way of, so basically if somebody asks this is not preferred, and it works with human preference, how humans, what people usually prefer. And prompt engineering is where once the model is done and inference, when we are asking stuff, you can actually like modify your prompt in such a way that like it gives you a answer. So you can impart knowledge into the LLM in all the 4 parts. We are focusing on fine tuning and reinforcement learning and some prompt engineering as well. Coming back to the next other 2 aspects of components of MapAI, the GIS and geodata. So what we chose for both of them is Postgres. So Postgres and PostGIS. So Postgres acts as the data side of things, and PostGIS as the GIS side of things. It's the reason why we did this is because it's open, it's scalable, performant, it has most of the basic stuff covered. So that we thought it will be a good starting point for an AI to do geospatial stuff. And it's also interoperable with other GIS software and programming languages so that you can actually start building up the capability of the model. It also is widely used Postgres in terms of database systems, and it's been worked out very well for us. So essentially, MapAI is a system which generates SQL code to do geospatial analysis using PostGIS. Knitting all these three together, simple, like a broad overview of the architecture is so we have same thing, the three components. Like we have the user interface, the AI model, and analytic engine, which is the GIS and the database. So and the questions and the information about the data kind of move through the systems. We use OpenAI and Llama for AI engine. We use PostGIS for the analytics and database. And we have built our own UI for now using React and XGL and things like that. The whole thing lives in AWS. Using the AWS offerings in terms of cloud. So that's how we deployed and we developed the things. So we're almost half an hour in. So that kind of sums up what we have done. How did we do it? So to summarize, so there are three components to it. One is the generative AI, GIS, and geodata. GIS and geodata, we took the easy way, but more extendable way, which is Postgres. So we took a basic SQL system with geospatial capabilities as this. And we spent most of our effort on getting that LLM, teaching the LLM Postgres and PostGIS, and building the systems around the LLM so that it seamlessly works for the user who asks a question and gets the answer easily. And all of them are stitched together and deployed with the AWS and cloud stuff, which we've been working on for the past 5 years with other projects as well. So there's a lot of learnings which went into that. I'm doing what everyone shouldn't do in a live one. I'm doing a live demo. So let's see if it doesn't work. I have videos to show as well. So they're covered both sides, both ways. So let me try and, okay. There you go. You should be able to see a blank map with Sydney on it. Cool. So this, okay, so I have 3 instances which I wanted to show. One of them is the earliest one we built and has the most data set is the New South Wales Spatial Explorer. What it shows is, so what we did is there are 2 big data portals with made available by New South Wales government. One is Spatial Services Spatial Collaboration Portal. The other one is Heritage and Environment Seed Portal. So they have information on almost all the properties in all the built infrastructure and spatial stuff in New South Wales, along with some planning regulations which go with it. So we can start by asking what data sets are there. So that should give us a indication of what's in there. They have addresses, environment data, planning instruments, POIs, transport. So then I can start asking about okay, show me SA3 boundaries. So that should give us so it has boundary information from ABS, so it should give us SA3 boundaries. In terms of then we can start asking about the boundaries. So let's say, show me just the top 5 largest ones. So essentially, we are asking for the 5 largest SA3 boundaries in New South Wales. So it kind of does that for us. And then in context, we can switch saying how about Smallest 5. But here I know that there are like few null geometries which are like addresses without boundaries to them. So I can say like remove trees. There you go. So these are the 3 smallest SA3s. So that shows like, so we did not know what tables are there, what SA3s and what columns, none of that. So you just start asking questions about the information you need, and it kind of like start giving you the answers for it and insights on it. Also, you can see like which ones are there. So these are the null geometries which I mentioned. Doesn't migratory offshore shipping doesn't have any geometry. So Leichhardt, Maricul, and Manly are the smallest ones. So I can do more. Let's say like show me Sydney LGA. Not the north one. All right, so we got Sydney. How many people live there? That should give us the population. So that's coming from the census data set. There's a table of census in there. So we can naturally ask for things the way we ask it. So basically like I can ask like, how many people live there. I'm not being a social scientist, the most common way I'll ask is like, what's the population of Sydney LGA? But I don't think not many people ask that way. So it kind of helps us navigate through the information in a way naturally a person will do. And you can ask things like, what's the percentage of young people there? So that's 52. So for Sydney, LGA, and then you can in context change stuff, saying like, how about Randwick now? So in the conversation, we are talking about population percentage, young people percentage in Randwick is 45. We can also do like spatial operations, something like show Zetland suburb. That should show us the. There you go. And then you can ask like which postcodes cover this suburb. So that basically does a spatial join about like which postcodes are intersecting with Zetland. You can also do like more nuanced searching things, geospatial searches, such as find Green Square Station. So that should give us the station. Then you can say like show landlords within 250 meters of the station. So those are the landlords. Show, I know like some of them are heritage zone ones, so show just the heritage ones from the above. So the heritage zone ones, and then you can ask questions like how many are there? 5 of them, and total area of median size in so that shows like the kind of search functions we can do in terms of the way we think geospatially. We can actually ask the question rather than knowing and like doing the things ourselves. There is also like a lot of other reporting kind of stuff we push it through. So something in terms of like, okay, so we initially we had this around the time we started the project, there was a TO transit oriented development problem we had. So we were looking at things like show me all the government owned lands around railway stations. So that can be like show me Parramatta station. There you go. Then show state government owned land within 500 meters of the station. So that should give us like all the lands there. So this one, like basically we actually did the work as well, having going through GIS. now it's just a question array. So I can generalize the question for all the stations. I might break the front end because there's a lot of land around stations which they own. And you can also like ask for further questions saying like show total area in hectares. So that's like it's like showing all the one from above lots. That's 3.8 hectares there. So we also did like as I mentioned, like in addition to developing this as a showcase for testing and like developing the AI, we also did like 3 use cases with the councils. So one we did with Geelong City Council, which is around parking. So one of the key questions they had was like around like how finding parking for customer service, which is kind of people calling and asking like, where can I park around this place? So we can start doing something like show parking. So they gave us information on the parking bays there and the schedule that goes along with the parking bays. So, and then say like filter just parking in street. Hey. There you go. And then we can say like put only disabled parking from the zone. That should give us that one. So I also like have an address which I want to go, then I can say like find the closest one from above to the given address. Closest one to okay. There you go. The demo gods have been nice to us today, so it's so that shows the so for a person or someone who's looking for a parking information about like an address they're going to, they don't need to know, they don't have to know about like where the data set is, what are the columns there, and how they're going to find the information by stitching those two. So that basically shows like you can ask the question and then you can have like it's the same way you will have a conversation with the person who knows them. You can start having the conversation and going through drilling down the information you need. So moving ahead. So that's some demos I had for today. And then there are more. If you have time in the later, we can play through them. We'll go back to the. So I had like a few the videos in case like everything crashed and doesn't work. But there we go. So these are the ones. All right. So before we go ahead and see what we're going to the future, I wanted to address these things. These are the key challenges we faced in the project and the way we overcame or like trying to overcome them, right? So first one is the hallucinations and trust problem. So whenever that's like the main thing people have against like generative AI and chatbots around that. It's like it's giving me an answer. How do I trust it, right? So I've asked the same question for ChatGPT. It's like, give me the coordinates of Green Square Station. It gives me the coordinates. I ask the same here. It gives me the coordinates, right? But the difference here is like I can go and verify this and I know where the answer is coming from. So that's why like the code generation based approach where like you have the data and you generate just the method to get the answer helps us keep the trust and keep some hallucinations away. The second one was the performance of the model. The first question people ask like, how good is the LLMs doing geospatial stuff? So that's kind of like up in the air. It's a research question. So we're trying to find an answer, like a definitive answer to the question. So we're trying to develop a evaluation metric, which is spatial eval, which is like kind of like sees how good an LLM can be in geospatial operations. So it's very simple as of now. 50 question and answer pairs, which kind of like across like simple to complex questions, and we know the answers, and then we check the answers across our given data set. The very initial results are here that need to be like rigorously reproduced. And the other major problem we have is like nuances in terms of the natural language questions people ask. So an example would be schools in Sydney can mean 100 different things to 100 different people. Sydney can mean like different things depending on the context of who you are. Schools can mean different things for different people as well. So if it's a private school, it will be include universities and schools or not. So that's where we are spending most of our time, where like we do the fine tuning based on user questions and what they actually expect. So all the training which has went into it comes from the user ones. We don't create like training data from ourselves, because that kind of keeps us grounded to what people are actually asking and what they expect out of it. So that's the fine tuning part which is helping us overcome this one. And the last bit is like the ethical way of collecting data. So we kind of like haven't had, like, being a small project, we don't have the same data resources which Google, Facebook, and companies have, where they can just mass collect all the data, user data. So we kind of focus our efforts on getting users to the workshops, giving them access to the tools, and then like collecting data from them, and then using that to improve the LLM. In terms of those are the research ones. In terms of development, we have security of the user data. So here, again, like the way we organize the architecture helped us a lot, because none of the data goes into neither the fine tuning the data set or the inference from the data set that influence the AI. So AI never actually sees the data. AI sees a structure of the data at best, and it's trained on a possible structure of the data it can have. So essentially, like we can split the AI system away from the data system, which gives us completely like different silos for them to work in. And in terms of commercial sovereignty, so this also, like we spent a non-trivial amount of time developing our own Llama-based. So basically, we have like two models that we can use from. One is the OpenAI-based one, another one is open model-based one, Llama-based one. And that's the playground showing like them being tested against each other. So we're almost very close in terms of GPT 3.5 fine-tuned performance. So we are in our 17th iteration. That work is keeping going on. So that is to ensure the sovereignty of the questions and the user information which goes into that. And then basically like that's up for commercial data. So I think we're running out of time. We'll go faster. Performance in terms of user interface, we are using GPU accelerated mapping libraries to do that. In terms of production scaling, that's AI has so AWS has been like a immense support in like giving us support in using the infrastructure to scale them properly. And in terms of cost, there's also the serverless on-demand computing from AWS, which helps us deploy stuff and get charged only when they're used, not for the provisioning. So finally, like we also try to develop a automated prompt engineer module, which will optimize the queries for us, so that like we don't spend too much on the AI as well. What have we achieved until in the last year? So we have a prototype ready, which is working prototype. We have 3 use cases with partners. We won 2 awards with GCA, Geospatial Council of Australia, for technical excellence and innovation in business. So to sum up, basically, like there have been challenges in research, development, and the production side of things. We have found some of them. We have actually tried to overcome some of them, which and some of them we have methods. We're trying methods to solve them. We have been successful in getting first draft prototype product out, and which it works. Future. So this has been the big news like last week. So basically, we've been successful in getting a CRC project funding from the federal government with Akistar, Texa, and Akistar and Texa, and that's going to be 3 years doing a similar MapAI kind of system for Arkistar's development planning application related use cases. So it's an extensive project for 3 years, and I'm really looking forward to building that up. Future directions for me personally, research-wise, like I want to do more geospatial stuff, teach them more routing, more Python or R. So where like the more complex geospatial analysis sets, and Snowflake and DuckDB just because these are the emerging stuff which has been, they have been coming up big in enterprise side, especially DuckDB. It was like been hearing a lot of good things about it. I want to train MapAI on it. In terms of accessibility, we want to see more voice and languages, being able to like, so what MapAI like I can see can do is like, you don't have to speak R or Python or like geospatial to access the data, but in the future, it can actually remove the requirement of English as well, so you can speak any language to get the data you want. And another one thing which we want to explore is vision. So that's basically GPT-4o. I just gave the image and asked him to explain it. So those kind of image explainable things which we can do. So imagine like if I ask a question, MapAI produce the answer, then I can ask for insights from the answer, saying what does it mean for me? So that's the second question. Basically, I'm saying like, I'm from New South Wales. According to this map, is it better or worse for me? So it can actually like interpret that for you. So that's pretty much it. I think like we have 5 minutes of time. But to sum up, MapAI is basically a generative AI system which helps people to do geospatial analysis without using just natural language. We've been working on it for the past 1.5 years. We've partnered with Frontier SI, MapAI is UNSW spin-up now. We have a working prototype and like 3 use cases with real world use cases. And it's basically like we're really looking forward to like building it out for the future. That's me.
Okay, there are a couple of questions in the chat, and few already answered. So, would you like to probably give us more about the capacity of more information about the capacity of MapAI in the future to export the maps, something like Adobe Illustrator or any other platforms?
Yes. Yes. Technically, yes. Like so, once it's vector, you can export anywhere you want. The key thing is like as I mentioned, like the vision stuff is what's interesting for me, because once you so you ask a question from a geospatial data set, there's only so much you can get back in a table manner. So there are interesting patterns in maps only people can see. If we can get like AI to see those patterns and relay the information back to you, that will be like the next big step in terms of what we can do with geospatial stuff. So my example would be like, I can ask like, show me all the schools, and then show me all like the libraries. Then I can ask like, so can you find places where they don't meet, or like, can you find any patterns in them? If the AI can help us spot that, like that will be like the next one. And the sparks are there. So the vision models are already in a point like where we can actually explore that. So that's more interesting. Yeah.
The other question, did you just use the pre-trained model like ChatGPT, or did you fine-tune the model on your database? And if you did, how much fine-tuning did you do?
Okay, so as I mentioned, like so the initial prototype was like just 3.5, GPT 3.5, and we have gone through like I think 6 set of fine tuning for the OpenAI models as the models have been going up as well, and 17 set of fine tuning for the Llama 2 based models. Llama 2 is like really hard to fine tune because your context size is so small. Not the same problem with OpenAI, so you can fine tune as much as you want. So basically, like Richard, he has been instrumental in getting that Llama stuff. So basically, like all the prompt engineer stuff we've been working on, like trying to overcome that context thing, but I think we've got like to a level where it actually performs close to 3.5. To answer the question, yes, a lot of fine tuning, 17 steps in Llama 2.1.
There was an earlier question that saying when you were just explaining. Can you ask multiple questions and retain each layer on the map as you go? And Phil already answered no in this production version, but probably in the current development version. Yeah. And following up on that, what's more available in this current?
So as I said, like, so we are in the production end of the cycle. So we've got like a lot of, we worked on getting the prototype up and ready and working, and then we worked on getting the data for the proof of concepts to work and show that it works. So now we are working on the app development side, like where we're looking at like the things which can improve for a user. One of them is the layer management stuff, layer management, coloring, cartography on top of it. So it can we do like curve flood maps with the data that comes through. So we're working on those. In the future, so there is like tons of stuff that basically we can, the time is the only limit to what we can do. There's so much in there. Yeah.
Are there any other questions from the audience here?
I've got heaps of questions. I don't know how much time we have. Thanks, Mark. That's awesome. You guys are probably chuffed at where it is now. My first question was, I noticed that there's no like RAG or anything in your architecture. I was wondering whether you're considering that to improve any aspect of it.
Yeah, so okay, so basically retrieval augmented generation. So basically, so that has been we've been exploring that for a policy side of things, right? So it's more like, so there are two places where I think it will help, and one is like so basically like Chris and I've been working on that. So basically looking at meaning in prose. So as in like we do a lot of work which kind of is, it doesn't have a geospatial data to it, but it's actually prose. RAG is very good for that one. And the second one is data discovery stuff. So which is the spatial services collaboration portal has tons of metadata, which are there. And then there's like I think 600-page PDF, which describes all the data, which I spent like a weekend going through back and forth. RAG would be like insane for that.
I think RAG would like RAG for the metadata.
Yeah.
Like putting in all the database schemas, putting in the meaning of everything, putting in like policy documents and like other meaning would mean that then after you've got your result, which is a number and like some code, you then apply the RAG on top of that to give a really meaningful like few sentences.
Yeah. So that
and I think that'd be really cool. I think it would add a lot to it.
Yeah. So that's one place where we want to use it. With this, I've spent more time on getting the metadata cleaned up so that we can have a very robust end product. So that like actually, so luckily like everything worked today, no errors. So that's what we have been trying to get that up to that mark. So there's so much once the data gets so extensive that like one person cannot understand the whole thing. So you need like AI to help us do that. Yeah.
My second question was, it seems like, because you've already made a fine-tuned model, you've almost made an agent that is really good at retrieving data for like choropleth style analysis. Have you looked at doing like other geospatial agents on top of that, like maybe like spatiotemporal queries or like clustering or something like that on top of it?
Yeah, so there are two which I have in mind, but yeah, so we're working towards. One is the styling itself. So that's a simpler model which can do the styling for a given layer. Another one is more about like what type of layer it is, but making a type of layer. So for example, aggregation is like the second one, whereas you're making a different type based on the data there. So that's more complicated, so more complex. We'd love to do that like part as well, so we can actually connect them together. So the data comes in. That's where I think like the Python and R stuff will be very helpful. Having some like hill shade analysis agent on top of like the retrieval, so that'll be amazing. We haven't done any raster stuff as well, so that's also like interesting thing.
There is another question here. Can you ask questions based on your own customized area? Meaning not a GIS boundary such as a suburb or lot, but
Yes,
for example,
we can.
proposed master plan precinct.
Yes, we can. So one of the, I didn't get time to show that, but the Geelong one of the use cases they had was waste collection. So they have waste collection areas. It's like it's a very interesting data set. So they have waste collection areas which has a starting date, and then every third, fourth day, each area will get like waste collected. Navigating that is a mess. So basically, it's like a PDF uploaded somewhere, and people are like, I just want to know when the van will come in, right? So that you can do. So that's if you ask, like, I live in this place.
Are you guys experimenting with prompt libraries? I saw there was prompt enrichment.
Yeah.
This is something I struggle with. So it's like you either give the user heaps of examples of good prompts, or you just go like, type in whatever you want. We'll enhance your prompt for you to make it relevant and show it to you and see if you're okay with it, then send it.
Yeah, so that's basically that's an interesting one. And we tried like some prompt engineering stuff for optimizing the queries, but we haven't gone like deep into that asking people like if that's the right one. So that's like a two-step process where you want to know like the refined prompt is the right one. Yeah. Cool. Any other?
Okay.
So the information's always up to date, isn't it? Because you're getting it from on the chat GPT from the latest. So if the boundaries change, you get the most recent information, don't you?
Yes, yeah. So that's the advantage of like the code generation stuff. Basically, like it's as good as like your data, the data you're providing to the system. Yeah.
Okay, I think that's it. Thanks everyone for giving up the water. Thank you, everyone. Just a reminder that our next seminar will be held in 2 weeks by Professor Taha Hossein Rashidi, who will present his project on GPS-based smartphone integrated travel diary and time use data collection. Thanks, everyone, and I wish you a very good afternoon.